saying is that you want your function, right? Any kind of numbers on one side, and then on the other side, you just want 0. So if in the homework you see like variables on both sides, what you need to know is, hey, I need to move that from over here to over here. That way I have a 0 on my right-hand side. So some problems, that step's already done, right? You don't really have to move anything. So technically just write it as f of x, an inequality symbol, and then the number 0, okay? Our second step to solving these is actually to solve our function with it set equal to 0. So whatever we have, set it equal to 0. When we've done that, we've always found our x's, right? If you need a factor, y'all, then you just need a factor. If it's a quadratic, do the AC method, do quadratic formula, do whatever you need to do to get it into those parentheses, right? Parentheses is factors, so you need to factor it. So in 3.6, yes, x equals, that is an x-intercept for your graph, but what we're looking at is a number line. And so what they're gonna call it is a boundary, okay? Okay. So I make sure that I have a 0 in my function. They're separated, right? Whatever inequality is the inequality. I take my function, set it equal to 0, and then I'm gonna like solve for x equal whatever I end up solving, right? Our next step, what we're gonna do is these boundary points like x equals 4, x equals 3, we're gonna actually graph them on a number line. Honestly, whatever x equals, it's like you're doing a dot, right, on a number line. You're just gonna like plot that point. And then, and I'll show you, all this is gonna be longer to write than it will to understand, honestly. After you do your points on your number line, what we're doing is we're dividing that number line into different intervals. And then our step 4, right? I just now plotted these points on this number line, and I've divided my number line into all these different little sections. For step 4, what you do is we're gonna pick a point in all of these different intervals, and we're gonna evaluate it. And then y'all, I'm lazy. Right here, you can write positive or negative question mark, right? So then again, it'll make more sense whenever we actually do a problem. So once I have it divided into intervals, I pick a point in my intervals, I evaluate it. Say my point's 3, I'm gonna do f of 3, right? That's what it means by evaluate it. Actually figure out what the answer is to f of 3. And then whatever my answer is, whatever numerical value I get, the only thing I'm really super concerned with is that value positive or is it negative? Okay. And then lastly, it tells us to write the solution set. I spelled solution like that because I'm lazy. Write solution set of intervals that satisfy the inequality. That's going to, again, also make a lot more sense whenever we do the problem. But just as a quick example, if our inequality looks like this with a less than, do y'all agree with me that if something is less than 0, then it's a negative value, right? So if I get down to this point, what I'm looking for are those negative values. That means it would satisfy that inequality. So if it's greater than 0, then I'm looking for the ones that ended up being positive, right? Our solution set is going to be written in interval notation. That's what the parentheses or the brackets. And when you have multiple interval notations, don't use the U on your keyboard. Like on the bottom of the homework, it's kind of like a big fat U. What that is union. We're actually going to union together multiple intervals. When we do a problem, you're going to be like, oh, that makes way more sense. These are just words. So let's do this first example. I like literally haven't gotten out my markers yet. Okay, so problem 1, what we're going to do is in parentheses, y'all, we have, I'm going to try to use different colors. We'll see how it works. We have x and a -8. And then in our other parenthesis, we have x plus 2. I have to keep this right here. I got to make sure. Okay. So problem 1, parenthesis, we have x, a negative 8, open parenthesis, x plus 2, close parenthesis. This inequality says it's equal to 0. Y'all, that step 1 said to express it with a function, an inequality symbol, and then 0, right? This is already done. Yes. X minus 8, yeah. And then x plus 2 greater than 0. So it's already, we don't have anything to do for that first step. It's already in that form, okay? So y'all can write however you want as far as your notes. You'll notice, like, I kind of wrote things for a reason at the end. We've already said that we agree that inequality symbol means whatever's over here needs to be greater than 0, right? So things that are greater than 0, those are positive values. Okay? This is telling me what I'm looking for whenever I do my test points are positive values. Do you also agree that as far as doing interval notation, if this is our inequality symbol, do we do do we do brackets or parentheses? Parentheses. So that means I'm looking for positive in my interval notation. When I do the interval notation, I'm going to use parentheses. Okay, so step 2 said to solve f of x equals 0, right? Y'all, this is my f of x. So what you do is you actually set it equal to 0. So you do x minus 8 and then x plus 2 equals 0. Have we or have we not done this like 100 times, right? Like constantly, you have factors, right? Parentheses means that these are all factors. You have factors set equal to 0. What you do is you set them both equal to 0, right? Wouldn't I get x equals 8, x equals negative 2? Okay, so it told me to set it equal to 0, right? And then it told me in those notes, it said x equals a boundary point. Then the next step tells me to graph those boundary points. What I'm doing, I need to write kind of big, y'all, because these markers are thick. What I'm doing is on a number line, find these points. You do not, believe me, have to do 0, 1, 2, 3, 4, 5, -1. You don't care about any of those points. I only care about these boundary points that I got from solving f of x equals 0, okay? So it told me to graph them, really. I mean, you're just gonna, if you wanna do a point here, you can. You just need to know that that's where you're looking. It said to divide into intervals, right? Visually, doing this is gonna help. How many intervals do I have here? 1, 2, 3. All right, if I have 2 boundary points, I'm gonna have 3 intervals. If I have 3 boundary points, I would have 4 intervals, okay? So that's me actually taking the number line and I divided it into intervals. Now it told me to pick a point in my interval. What I suggest doing first, do I have a grade? I probably do have a grade. What I suggest doing first before you pick your point is let's actually write what these intervals are using interval notation, okay? Because our step 5 said that our solution set is going to be those intervals. So if we go ahead and already have them on there, then we already have them whenever we do our answer. Y'all, this is saying basically that I'm looking from -infinity to -2, right? That would be this part of the number line. That's the interval that represents that part of the number line, correct? Okay, so now what about this interval? -2 to 8. It's literally just parenthesis, -2, 8, parenthesis. And I know I'm using parentheses here because I'm taking that information from what from what my function has in it. If that was a different inequality symbol, one that says or equal to, I would be using brackets here. Of course, not on my infinity, so right. What about this right-hand side? What do we get? 8, and then to positive infinity. Okay, so now I have my intervals, I have my boundary points, I divided it, and it tells me to pick a test point in each interval. So looking here, I'm wondering on this number line, what is the next number after -2? Wouldn't it be -3, right? This is what I'm going to use as my test point. right? 0, -1, -2, -3. It seems backwards. Yeah, because you're like to the left of it, but because it's negative, it's still bigger. It's just a bigger negative. Okay, so, and then what would a good test point be here, y'all, to use? 0? Yeah, because 0 is in between it. It doesn't have to be completely split down the middle. It honestly could be any number you want, okay? I personally, I'm going to use 0. Okay, and then what would y'all choose for a test point that's in this interval? There's really no wrong answer as long as it's greater than 9. Sorry, why did I say that? I always say that. As long as it's greater than x. Why? I'm done. I give up. I'm gonna not ever teach math again in my life. Okay. The test point here, y'all, it really does not matter which one you pick as long as it's greater than what? 8. Thank you, class. I'm just seeing if y'all are paying attention to me, honestly. Okay, what does it tell me to do next? Look it, graph it, divide it, pick a point. We just picked points, right? Now it says to evaluate it. So what it means by evaluate it, these points that I just picked, I'm going to do f of -3, f of 0, f of 9. I'm actually plugging it in to whatever my function is, okay? So let me actually plug them in here. This is your f of x, right? Y'all agree with that? So that's what I'm plugging into. So if I do f of -3, looking at this, that would be a -3, -8, close, open, -3, +2. Okay, so -3, -8, signs are the same. You add and you keep the sign. -3 and a +2, signs are different. You subtract, keep the sign of the larger. Now if you do -11 times a -1, you get 11, signs are the same, so it's positive, right? This is that part in step 4 where I had written plus, comma, minus, question mark. What I'm looking for here is after I evaluate, is that a positive value or is that a negative value? It's a positive 11, right? So like not even trying to trick y'all. That's a positive value. You can write this however you want. You could actually write positive. You can do a check mark. You can write satisfies. And what all of those things mean is I said right here that something is going to be greater than 0, which means it's positive, right? Our ending is to actually write what satisfies this statement because this is a positive number. It satisfies this. That checkpoint, what is going on today? That check mark means that this interval notation is going to be a part of my solution set. If I'm looking for a positive number and I get a negative number, I'm going to do an X, which means that interval is not in my solution set. Does that make sense? Yeah? I don't know how y'all understand me. Okay, so now we're going to do the other test point, which is 0. F of 0 equals, okay, so open 0, -8, close, open 0, +2, close. Signs are different, so you subtract, keep the sign of the larger. These signs are the same, so you just add them and keep their sign. 8 times 2, 16, signs are different, so it's negative, right? Okay, does this negative match the fact that we're looking for a positive? Right? It doesn't because it's negative. So you could write negative if you want to, or you could just do an X. That would not satisfy this inequality because I'm looking for positive values. So there's another thing you can do, and I recommend doing it because you'll see a pattern. This 11, this 11 came from us testing -3, which came from this interval, and it was positive, right? So you could do a plus sign right there. When I got -16, that came from plugging in 0. My 0 came from this interval. My 16 was negative. So you can do a negative sign right there. And you're doing this for a reason, y'all. On the next problem, you'll see what I mean. Like it's a shortcut to not have to solve every single one, okay? Once you get to this point. So now we do f of what? F of 9. which would be open 9, -8, open 9, a +2. Signs are different, so you subtract, keep the sign of the larger, signs are the same. So you add and keep, and then 1 times 11 is just 11, right? Does that satisfy the inequality, right? Positive, positive, they're the same, yes. Check mark, it satisfies. Okay, so here on my number line, I would do a positive. There's an actual table for you to do all the steps. This, no, you don't have to do this. Okay, so it says like, what does that practice exam say? Pretty sure I would have written it. No, I just said solve the inequality on here. You will actually need to factor it, show your x's. You should say whether or not it's positive or negative, and then these two last steps right here. But as far as you plugging stuff in and you doing that, like you don't have to do that. You could literally just say you could say like f of -3 equal positive, f of whatever equal negative, anything like that, okay? So the last step also told me to write the inequalities that satisfied or that were satisfied by the intervals, right? That's my solution set. So this is why I said to go ahead and write these first. I knew I was looking for positive. Doing these signs lets me know that these intervals are positive. So these are the two intervals that make up my solution set. So my solution set is literally -∞2 unioned with 8, infinity. And then it will tell you to graph it. On the homework, it's like pick which one is correct. On the exam, there's an actual little number line and you'll have to graph it. So because I'm graphing this, the only thing I care about are those values 2 and 8. So I'm just here at 2 and 8. Thank you. -2 and 8. So my inequality 2 right here. Oh, y'all didn't even tell me up here either. I thought y'all left me. Now I know different. Kidding. I don't know what is up with me today, y'all. Could be 3 hours of sleep. Okay, so if you actually graph this one, because this, inequality symbol was a greater than, I even put here, y'all, use parentheses, okay? That was to use for my interval notations, and that's to know what to goes here. So it goes like that. Very ugly, but that's a parenthesis. And my line. And then an arrow that just states there's not another boundary, right? It doesn't stop anywhere. It keeps on going. Does that make sense, y'all? Yeah? In spite of me, it still makes sense. Okay, so we're going to do the second example. Okay. So it's x squared -11x positive 18. Y'all, this one also happens to be greater than 0. So x squared -11x positive 18 greater than 0. So am I looking for positive or negative values? Yeah, greater than 0 means positive. Looking at that inequality symbol, I know that for my interval notations and whenever I actually get to that last graph it on a number line, I'm using parentheses, right? I think I'm done using different colors, y'all. My brain's already going all over the place. Okay, so it told me what I need to do is to set my function equal to 0 to be able to solve it, right? If you want to go ahead and write that quadratic equal to 0 and then do what I'm doing, that's fine. Because I know I can just go ahead and factor this, I'm going to set those factors equal to 0. you could either use the quadratic formula, you could use the AC method, use whatever you want, as long as whenever you do factor it, those are the correct factors. So instead of just writing this equals 0 and then doing this, I'm like skipping a step, okay? I know I need x's. I know 2 times 9 gives me 18. I know -2 and a -9 combined to a -11. And their multiplication would be a +18. So y'all see how I got that? Okay. So because I have factors set equal to 0, what you do is you set each factor equal to 0. What I would get is x equals 2, x equals 9. These are what they call your boundary points. On a number line, plot those points. 2 and 9. You really just need 2 lines and then put whatever your values are, y'all. Okay. So do you see how this is splitting this number line into 3 different intervals? Okay. So now the question is, what are my intervals? So you're just going to look. This would be from -infinity all the way up to that +2. Y'all, with infinities, you always use parentheses, right? I know to use a parenthesis on my 2 because that was that first little hint that I gave myself. The interval notation for the middle interval would be what? Just 2, 9. Yeah. And then for the right-hand side, 9 up to +infinity. I think there's one problem on the homework where you put what the interval is and then you write if it's negative or positive. And that's after, of course, you've evaluated a point. You know what I mean? Hopefully it's clear on the test that like what I want you to actually put as an answer. Now what do we do? Plot some points. It does not matter what your numbers are, you're going to end up getting, if I get a positive when I do a certain value, you're still going to get a positive if you do a different value, as long as it falls within the correct interval notations. Okay, so what would we use? I think I used 1, 4, and 10, right? 1 is right before 2. And then in here, I just picked a number. It doesn't have to split that equally or anything. It could just literally be any number in between 2 and 9. And then I picked 10. So these are the points that I evaluate. So, okay, so whenever I did it, I actually plugged these like test points into this right here. I don't know why I just did. You could also just plug it into here. Okay, it really doesn't matter because one's just a factored version of the other. As long as you do F of your test points, you could use either, whichever one's going to be better for you. I think it may be better or easier to do the factored version. And I usually complicate things. So maybe that's why I did the other one. So 1, -2, open 1, -9. Signs are different. So you subtract to keep the sign of the larger. Signs are different. So you subtract to keep the sign of the larger. 1 times 8 is 8. Signs are the same. So it's positive. And it was like a less step. Okay, so this one's positive. And the first thing I wrote whenever I looked at this problem was that I was looking for positive values, right? So as far as whether or not it satisfies or it doesn't satisfy the inequality, you could just do a little yes, right positive, right satisfies. I'm also going to add right here, y'all, my big plus sign. Let me show you this. This is that previous problem we just did, right? Do y'all see a pattern? So that is the pattern, okay? Technically, if you can see that pattern, you should already know now which intervals are going to be in your solution set, okay? So, but I'm going to go and do the next one. I would go ahead and evaluate at the next test point, which would be F of 4, which would be open for -2, close, open for -9, close. which would be signs are different. So you subtract, keep the sign of the larger. Times signs are different. Subtract, keep the sign of the larger. 2 times 5 is 10. Signs are different, so it's a negative 10. Does that satisfy my inequality? No, because it's negative. I'm looking for positive. So here I would have my negative. Question. Is this value going to be a positive one when I evaluate it or a negative one? It's going to be not like a negative number one, but just like a negative value or a positive value. It's going to be a positive value because there's a pattern, right? So whenever I use the intervals that satisfy my, my problem here, I can just write my solution set as this interval notation and this interval notation. Using union in between them. There's definitely similarities in the two problems that we've done because we factored it into two different factors. On the homework, they might have where it looks like this and there's an X here. So that means I would actually have 3 boundary points. So I would have divided it into 4 different intervals. You see what I'm saying? Like, I don't want y'all to pick up on the similarities and think every problem's exactly the same. These two do look a lot alike though. 2 and 9. And then here and here. Y'all good with this? Yeah? Okay. We're actually going to get to do more of the review. I do want to say one thing though. There's 2 problems on the homework that look like this. When you can have these, you can have these. I'm gonna have to edit like the first couple of minutes of this video. Honestly, how many times I messed up, I shouldn't even post it. So I might just go home and record like this great, awesome, no mess up video and I could post it for everybody, okay? There's 2 problems on the homework that look like this. And I'm literally just I did this in the last class. My favorite numbers are 6 and 13. So say it's x plus 6 over x minus 13, less than or equal to 0, whatever, right? Do y'all notice how that's kind of like a different form? This is a rational function. The ones we were doing were not in this form. So as long as you have a function, your inequality symbol and your 0, step 1's already done, right? You don't have to move anything. Step 2 was to actually set your function equal to 0, right? What you do is you set your top equal to 0 and you set the bottom equal to 0. And then literally all from that point forward, it's the exact same problem, okay? It just doesn't look the same at first. You almost think you need to set the whole thing equal to 0, but then what would you do? You'd multiply by the denominator and now you just have 1. So just set the top, your numerator equal to 0 and the denominator equal to 0. You'll find your boundary points that way. This one you would use brackets. Yeah, for this one you would. That's why I kind of was like, So if we saw this, bless you, like our little notes to ourselves, we would be like, okay, so something that's less than or equal to 0. Well, if it's less than 0, already I'm looking for my negatives, right? And then because it's this inequality, I would use my brackets. I kind of just wanted y'all to see the whole, like in this form, you're going to set both numerator and denominator individually equal to 0. I think there's 2 of those on the homework. On the exam, it's not one in this form. It's one in the other 2 forms that we just did. Okay, and then I think the table is like inequality. I actually have inequality, and then I even wrote negative or positive. So in this first, like, row 2, column 1, you would write, say, negative infinity up to 3. And then in the next column, you would write positive. So I don't really care about if you did the math here or whatever. Just tell me that value when you evaluated it, was it positive or negative? You see what I'm saying? And then I actually wrote the word solution set. and then I actually pasted like this little number line, okay? It looks similar, I think, to the first problem on your homework. Okay, so let's do a few problems from the exam review. Got like a solid 12, 13 minutes. So hopefully we can get through like a couple of problems. Y'all can't see when I write in pencil, can you? That would be freaking awesome. So awesome. Let's see if you can. Oh, I don't like this pencil. Barely. Let me zoom in and see. And then what is this? Whoa, I don't like this pencil. I use the green one usually. I wonder if the things are different. You know what I mean? Like for the lead. Okay, if someone's literally like, okay, I'm done squinting, I really can't see this, I'll switch over. But those markers, you use them and then they get even bigger and bigger and bigger. I don't like them. So just to reiterate, know this review, okay? Know this review, like back of your hand. I think you'll do well. Okay, problem 1. On the actual exam, of course, it's not in this format that you see here. It's more of like an actual problem written in English that says state whether the function opens up or down. Does it have a minimum or a maximum? If so, what is the point? Do you see what I'm saying? Like it's not, this was just me kind of as a student, just being like, okay, this is the function, this is what I'm looking for, okay? So looking at the review, because I don't have the, Wednesday. Yeah, so Monday we'll finish this, okay? This is what I mean, like I just want to come in and like just y'all let me solve it so we can get it all done and you can see the work, okay? Instead of me going like really slow. Okay, so problem 1, it gives me f of x equals x squared, that's a positive 4x, and a negative 12. I notice it in the problem. Not only does it ask me to find specific things, but there's little blanks down below. So I know what I'm finding, right? I need to know if it opens up or down. So the way that you know whether or not this would be a quadratic function, right? Quadratic is the highest degree is 2. Polynomial is 3 or more, right? And then the rational is whenever it's written as a fraction, right? So the form of it should already kind of tell you what you're doing. If I'm looking to see if it opens up or down, this would be my A, right? And my A is greater than 0 because that's a 1. And if it's greater than 0, does anyone remember, does it open up or down? Up. So we could say opens up. And the way this would look would be like this, right? Huh? The value, that's your A. So do you agree with me that this is in ax squared plus bx plus c form, the form of a quadratic, right? So we had those two forms. One was like the standard form, one was the general. The standard form looks like that second problem, right? Our A here is that 2. And then the general form is when it just looks like this problem, like a quadratic formula type of problem. And your A is that very first number there. So as long as that value is bigger than 0, then it opens up. So bigger than 0 is literally 1, 2, 3, 4, 5, 6, right? So a positive number. If you have something in this form and there's a negative sign right here, a negative number would be less than 0. So it would open down. These problems, honestly, use your calculator, put it in there. You're going to see it opens up. You might not be able to use that fact to answer all the other problems, right? You still have to solve all of the different, like the work that the problems ask you to do. But using your calculator to see certain things and check yourself is never a problem, right? So if I entered it into my calculator, I would verify, yes, it opens up. Now, it told me that it wants to know if it has a maximum or a minimum. Y'all, if we, I'm gonna actually, I just know where it is. So say this is actually on a graph, right? I can even see it on my calculator. If it's asking if it has a minimum or a maximum, all parabolas that open up have minimums, right? Looking at the y-axis, the value of this graph is, this is the smallest value on the y-axis, right? It doesn't include all of these negative y values. It includes all the positive y values. This is the smallest y value, so it has a minimum. If it opened down, then it would be the other story, right? It would only go so high on my y, so it would be called a maximum. So open up always has a minimum. So I just wrote has minimum. And then what you could say is at, okay, it was, hey, does it have a minimum or maximum? If so, what's the point, right? When you give the point of a minimum or maximum, it wants, where does that occur on your x-axis? So it has a minimum. That answered a third of the questions, right? At x equal, that's what we need to figure out. Okay, so when it's in the form of that second problem, I know that if I find the vertex of that parabola, that ends up being right here, right? That would be like what splits it down the middle. That would go ahead and give me my x, right? That's when you find the h and the k, but this isn't in that form. This is in that annoying form that you need to use this right here. I have this on the exam. I don't like explicitly state which form this goes with. You just need to know if it doesn't look like this and you're trying to find a vertex, you need to use this. So y'all, this negative b over 2 times a, that finds my x, right? So what would this end up finding? X comma y. Am I looking for my y? I'm only looking for my x. So yes, I need to use this formula, but I only need to do half of it. I just got to figure out what this x value is. I don't care about them plugging it in and I'm not needing to tell you my y anything, right? I just need to know where does this minimum occur, which means where on the x value is the lowest point of this graph. So we're actually going to use, so it's like you're using half of the formula, right? So negative, what is my b, y'all? So negative, I got a 4 over 2 times a. What is my a? 1. And so that would just be 2 times 1, which is 2. You're right. And then if we do this math, 4 divided by 2 is 2. Signs are different, so it's negative. That's my x value, y'all. Okay. Right here, it's hard to write because I write big. Right there, see, little bitty baby 2, negative 2. That's my negative 2. That's where this vertex happens, which is the lowest point of it. Therefore, it's my minimum. Okay, so as far as your work, it's, A opens up because A is positive. That means it has minimum at, find your X, okay? We got to start problem 2 in the last class. I think we might be able to finish it in here. Does that make sense, y'all? Maddie? Negative. Yep. Yes, thank you. Okay. Let's do problem 2. See, way better pencil. Problem 2, it has a list of things that I'm finding, right? It says that I need to know whether or not it opens up or down. I need to find the vertex, the axis of symmetry, the X-intercept, the Y-intercept, and graph it. So that's a very involved problem, right? But hopefully that's not intimidating to you. The function itself is f of x equals, I got 2 open, x minus 3 close squared, and then a negative 2. So as far as this opening up or down, that depends on my a. In this form, that's my a, right? Is 2 greater than 0 or less than 0? Yes, class. It's greater than 0. Therefore, opens up. Which would look like that. So in the little blank that says opens up or down, you write the word up, right? And then it'll say vertex. Now, what's great about this form, y'all, this is where my vertex was just H comma K, right? I can go and write that here, H comma K. I don't have the form written, but it should be A times X minus H all squared plus K or whatever, right? Like that's the form. I have that form and then the regular quadratic form. And then both of these ways, I don't know where my work went. Oh, this HK and this on the top of the exam. I just don't say which goes with which. You need to know that. Okay. The one that looks like you could use the quadratic formula is the weird ugly, because actually that's where the quadratic formula is derived from, is this. It's actually beautiful, but I know you don't care about that. This one, right? The one that's in the H and K form, right? You use H and K to find your vertex. Okay. So literally, y'all, what you do, this is your H, this is your K. Whenever you have your H, whatever sign you have in your function, your H's sign is opposite of that. So it would actually just be 3. And I can have a long drawn out explanation of why. I have a video about it, okay? And then my K is this actual value and the sign you see here, okay? So it is a -2. So literally, little blank, parenthesis 3, comma, -2, parenthesis, right? Just answered that question. Now it wants to know your, I'm just writing SYM, y'all, but it wants to know your axis of symmetry. Your axis of symmetry. So do y'all agree with me? Because we're going to have to graph this anyways, right? Let's go ahead and start it. Okay, so this is my X, right? That's my Y. So X is 1, 2, let's say that's 3. Let's say that's 2. Because this opens up, it has a minimum, right? I'm not going to draw it right now, y'all, right? Because I need to know where it's actually going to intercept on X and where it's going to intercept on Y. But I at least have enough right here. I can do my little point for my vertex. Your line of symmetry parabolas are like this. They're symmetrical. And they are symmetrical where your X is. And my X is what? 3. So the answer to axis of symmetry is X equals 3. That makes sense, y'all? Yes. No one's home, obviously. Okay, so this actually is right, exactly where I got in the last class. Because I know where this is going and because I don't want to keep y'all longer than you need to be here. So, and we're going to do it, but I'm just saying, do you see what I'm saying? This is finding the X-intercept. I don't want to start that and not be able to finish it. So we've been doing it, right? To do X-intercept, we're going to do it whenever Y equals 0, but we do F of X equals 0 and you just solve. And then we'll actually finish all the other problems. I'm just going to have to learn to just do a problem, not explain everything if I want to get through the whole thing. When I call y'all's name, you're free to go, okay? If you have any questions, of course, I'm here to answer them. Bye, y'all. How do you stop recording? I already forgot. Stop video. Nope. More.